Okay, we're going to start talking about data that could be used to look at path effects. First at Diablo Canyon in terms of some new instrumentation that has been installed that Marcia is going to talk about, and then we will go to looking at the differences of really Q in Arizona and in versus Southern California and potential impacts on the ground motion model. So, Marcia.
I'm ready. Thank you. Okay, yeah, so Norm asked me to review our ocean bottom seismometer project that we're doing and installation of a new seismic station. So that's the purpose of this presentation. So the OBS project, just to give you a little background first, this is a map of the, oops, there we go, map of the earthquakes, pardon me, this is a map of the seismic stations within the Diablo Canyon region, and the green triangles are USGS stations, the orange triangles are the PG&E stations, and we've been running a approximately 20 station seismic network since 1987. And in the last 6 or 7 years, we've been upgrading to digital. So all of the triangles that are circled are the digital. They're now digital, and they are dual, well, not dual component, but rather they are, they contain both velocity and acceleration. And then the little 4 blue diamonds offshore is the OBS project that I'm going to be talking about. So the purpose of doing of having an OBS project is, I'll show you a zoomed in picture in a moment, but is to improve the offshore locations. Our biggest seismic sources are the Hosgri, and the shoreline fault zone is also very important, and so we need to improve our offshore locations to hopefully get a better handle on the uncertainties in the locations, particularly in depth. So we want to provide full waveforms for both the big earthquakes and for the littler earthquakes, and on scale recordings for the larger events as well. And then we integrate them. We're going to the plan is to integrate them with the onshore stations. So presently, all of our stations are either telemetered for the analog stations or through spread spectrum radio. Go up to San Francisco to our earthworm system, and then from there directly they're streamed to the USGS. So anything that you get, any of the catalog data that you get from the USGS, you'll be able to get all the waveforms. And any earthquakes that are triggered uses the USGS system uses all of the available instruments. So again, just sort of looking at and more zoomed in. So the onshore stations here are now in squares with the black squares inside, and the offshore OBSs are then just the yellow squares. And then we've got the little green circles are various earthquakes, and these are all from Hardebeck, 2010, and the offshore faults are from the shoreline fault zone study. So again, our main concern was what's going on with the shoreline fault zone as it approaches the Hosgri. So we put together this plan to have 4 different locations, and let me go to the next plot. So the idea being that this would be a cabled system. It's a little bit hard to see, but all of this gray here in this bathymetry, these are all rocks. And we are not allowed to, we can't put cables across rocks. Other deployments, for example, in the Sea of Marmara, in Turkey, they've been able to do something similar, but each of their stations actually cabled directly to shore. We couldn't do that here, and also because we are, this hatchet area here is the marine protected area, and we have to stay on the westernmost edge of that. We also decided to stay within the 3-mile nautical mile limit, which is the state boundary. It cuts down on a lot of permitting. So there's a lot of factors went into deciding, not just trying to capture the Hosgri fault and the shoreline fault. And then in the yellow square, The blue is the marine protected area, and again, it was important to stay outside of the, stay to the west of this region in here. They wouldn't allow us to put any cabling or instrumentation at all. So the program consists of 4. The blue diamonds here are the 4 permanent stations. The plan is to have them in place for 10 years. They're cabled for both fiber optic for data and power. And so each one then is cabled together, and then the last one then goes in through the intake. And I'll show you a blow-up of that in a moment. We also have 4 temporary OBS units, and originally we wanted to put 2 in for 2 weeks, take them out as a noise survey, and then take those out and put 2 more in, and then do a noise survey test. We're doing the noise survey test, but we've had to modify that because of issues we had when we first deployed back in July. So phase 1 of the deployment is complete. We have all 4 units are down. The cables are down, but we ran into some problems with the cables. So phase 2 is to go back in, and unfortunately we're going to have to pull up 3 of the OBSs. The 4th OBS, which happens to be this one right here, is working just fine, and I'll show you a little data sample as well. So we're very excited. We've got 1 of the 4 working right now, and by the mid-November all 4 should be working. OBS 4 is also now going through directly to the USGS. So the data are public. Just to show again, this is what we've had to consider when we're laying the cable. So the sandy part are the lighter, and in here is the rockier areas, and you can kind of see as we're snaking our way in here, that was a pretty dicey design, and we actually had to have a pre-deployment ROV survey first to map out where we wanted it to go, and then what we're trying to find are little sand channels, which we feel we have found. We'll know for sure after we finish the deployment. We do a post-survey ROV survey. That's part of the requirement from Coastal Commission and state lands. That's how they set their lease for us. Okay. This is just a picture of what the permanent OBSs, there's instrumentation. There is a broadband seismometer and an accelerometer. And on OBS 4, there's a differential pressure gauge. These are 1-ton cement caps. They're 6 feet in diameter approximately, and about 1.5 feet high. And they sit on top of the instrument. So this is a picture. So the upper left is you're seeing we're bringing the OBS with the cement cap, and you can't really see it very well, but this is sitting in here. So what they do is we put it onto the ship, and then they have a way of them affixing it underneath. And then the bottom one is just showing this is what off the edge of the boat. That's how it's deployed. That's how each one is deployed. And then this is a picture of the intake. So the cable comes into the intake and goes to shore. There's a conduit here, goes under the road and into this building right here. So that's where we have our recording units, and the data transmission to San Francisco is in the nearshore building. And so for this part, we had to have divers actually help bring the cables in. This was a rather dramatic bringing in of the cables from OBS 4, which was about a mile offshore. So this boat here, this little tug had to go in first, then this one came in, and this tug, the intake structures are over here on the right. We had to make sure that the big boat didn't run into trouble. So the tugboat had to be there to guide it to where it needed to be to a certain point, and then they turn it off, drop anchor, and then the divers take over and then bring the cables all the way to shore. So it was quite a process. And then both those boats had to leave again and not hit anything. So it was pretty dramatic. this is what the temporary units look like. And so, again, what we wanted to do was to do sort of a month altogether in 2 different locations to kind of sample. But we had to drop them near the end because we had some both equipment and weather issues which delayed us. And so we just put them in and left them, knowing that we were going to have to come back to finish up the deployment anyway. So these have been down since the end of July, and there's also a broadband and accelerometer in there. And so we know they've recorded a few little earthquakes, which has been nice, and so it's more data. So we'll be pulling those up. The interesting point on these things is, so these are just dumped overboard, and they just sort of sink. And then we have the GPS that figures out exactly where we dump them. The ballast that is on the bottom here, this is a cement ballast. Normally for people who do temporary deployments in the federal waters, they can just, they use an acoustic release and the temporaries come up. That whole white part with the orange comes up, leaving the ballast on the seafloor. But no, we can't do that because we're in the marine protected area. Nothing can be left on the seafloor. So we had to engineer a way to release the ballast and have those come up as well as the temporary units. So the only thing we could leave on the seafloor are the permanent stations and the cables, which the idea is that the cables would then work their way into the sand. So this is a map of the area. So again, with our onshore stations, and the earthquakes in yellow are since July 27th was when OBS4 began. And then the earthquakes since 10/7 was when, I call it our Kappa station, was deployed at Diablo Canyon. So I'll be talking about that in a moment. But just wanted to show you a couple of recordings. So we have we were able to, this is from OBS4, we were able to record, there was this is about a 2.7 earthquake up in this region here, and this one here that's not to scale on magnitude, but this was a magnitude 4 that occurred. So just to give you a data sample. So the magnitude 2.6 that occurred near San Simeon, about 40 kilometers away from OBS4. It's a very nice record. We're very happy with the data that we've been getting. We do have to do some filtering, which I'll show you in the next slide, just the ocean, from the ocean noise. And that's part of what we're just starting to deal with, is to devise the right filtering to put on these. They're pretty much, you can use some relatively generic filtering to get rid of it, but that's part of what we want to study, and it was the reason we added a differential pressure gauge as well.
Could you read the time scale, please?
The time scale, yes. Okay, the tick marks they are 10 seconds between here and here. Okay, these are 10 seconds mark. Okay, and top is vertical, and the bottom two are the horizontals. So this is from the broadband. And then this was a magnitude 4 event that occurred to the south in August off Point Conception. So the top 3 traces are the differential pressure gauge. We actually set them at 3 different sample rates. The broadbands are set at 200 samples per second. The differential pressure gauge, you can actually have it come in at different sample rates. So we're actually showing it at 50, 100, and 200. We're likely just going to lop off the 50 and 100, just so we can sort of get to know what the pressure gauge does and what it looks like. So you can also see that the pressure gauge as well can record the event. And when you've got, this is magnitude 4, so it's when they're big enough, the ocean noise kind of basically goes away. I mean, it's the amplitudes of the waves are larger than than the ocean waves. Okay. So then now I just want to show you a little bit about our new station. So the goals of putting a station just in the Diablo Canyon area are to install a recording station on the same rock type and at a relatively close proximity to the power block. We wanted to record small to moderate earthquakes within about 50 miles or so and integrate the recordings with USGS. The Central California Network and the PG&E Central Coast Seismic Network. So again, this is not yet hooked up to go to the survey, but it will be. So in deciding where we wanted to go, this is a map, a geologic map showing, so the power block is right here. So this sort of, I guess, greenish area here that shows, so this is the area that we were looking at. This is shaded so the area looks like a different rock, but it's just because it's a steep hillside. And this is what where we ended up putting something was in a temporary site because it was very difficult finding, we wanted to get something down to start the process. Let's just start getting some data and see what it looks like. So where the red circle, this represents, and this little knob here is a man-made fill area where there's a gate that goes a little bit to the left out here, and it's called Gate A. And there was some other, there was a guard's shack there. There was already, it was actually a nice flat area to put an instrument, so we decided let's just put it down there for right now. We've also we hiked around in this area here. There are some rock outcrops. There's some potentials for a more permanent station. But like the OBSs, this will also be, we'll also have this in for about 10 years. That's the plan. Okay. So again, just looking at it a little more close up. So this is a close-up of this here. So, and as you can see, and there's even some sort of arcuate-looking features here suggesting it's sort of sliding downhill. So it's obviously not the most optimum spot for a recording. So it's basically sitting on this same rock as the power block, but not locally, certainly. And this is what the site looks like now. So you can see, here's the units 1 and 2 right here in the distance. And these are not part of the installation. The instruments are in here, basically in the green box, well coupled to the ground. And it's called GAD for Gate A. Anyway, we're using RevTech 130s data logger. We're running this at 500 samples per second. We want to try to get the best smaller events, but being that this is a noisy station, we're going to be playing around with the sample rate, which is not hard to do. Let's see, they're L4 velocity sensors, and it's a 3-channel. So there's no accelerometer here. We just put basically a velocity sensor here just to see what we could get. And there was a little event. The orange, there's a little event. Let's see, it's right up here, and this is another 2.6 event. And and this is what it looks like. So the top 3 are the OBS4. So this is a lot smaller earthquake, about the same distance as that magnitude 4.1. But you can see when it's a smaller event for the OBS, you do have to worry about filtering. So what we're looking at, you're looking at basically the ocean noise here. This station here, this 3-component station here, and these 3 here are stations that are onshore stations, and they have good signal to noise. They're good stations. Just put them on for comparison. And then this is the GAD station. So there's obviously something wrong with the vertical. In fact, we're working on that this week. We hope to have that solved. But you can see the signal to noise is not very good. And this is 200 samples per second. The onshores are 100 samples per second for the velocity and 200 samples per second for the acceleration. And this one is 500. So we're looking at variety of sample rates and degrees of noise level degrees. So I did a sort of a really quick, I'm not showing it here, but just a little chunk of the noise to look. There's some harmonics that I think are, there's some AC noise nearby coming from those instruments or whatever those things are that are near the event or near the station. And there is some ocean noise, but I think it's more just at the ground. So this will be a good impetus for us to look for other places, because it's a good temporary site, and it's a good start. And for larger events, the signal to noise won't matter as much. So from the TI committee, I was asked, are there any data to constrain the path from OBS and onshore? And we do have several events. We've got several events onshore, and we do have a few offshore. And looking forward to, when we pull up the temps, to be able to get more data for the offshore to sort of add to what we've been able to record already for OBS4. And then installation of additional seismometers. We're looking for a better site for our station. GAD. Norm and I originally looked at some locations closer to Unit 1. There's a lot, it's very time consuming to go through the process when you're trying to put a seismic instrument in the nuclear facility within the protected area, not to mention costly. And it's awfully close to the Unit 1 and a lot of noise source.
I think that's our bigger problem of we want to be close to the power plant, but those are noisy places. So
right.
We're struggling with getting far enough away that we can pick up the small earthquakes, because that's our goal, is to be able to get those, yet be on similar rock conditions, and that's the trade-off Marcia is talking about here.
Right. We do have, Diablo Canyon has, I think, I'll just say 12 approximately of their basic system, their strong motion system, and supplemental. So we'll have lots of recordings for the larger earthquakes, but the goal is to try to get some of the smaller ones.
And really we're trying to get at, can we find something for path effects offshore, so starting to see how the data come across, and is it different than the waves coming from San Simeon and Parkfield, where we've had the previous earthquakes, because that's what we're using. Eventually this data may help as well with the velocity model offshore too, in what's happening.
Yeah.
So there's a long-term goal here, but for this project, really, it's data that's going to be available in the next 3 or 4 months, and then that's about all that we can try to use at that time.
Okay.
Any questions for Marcia?
Go. Right there.
Quick question, Arben Pitarka. What's the depth of the water column above the instruments in the water?
At OBS4, it is about 100 meters.
That's the
90
deepest one.
90 to 100 meters. The farthest out to the west gets out to about 130 or 40 meters.
Okay.
Right.
Marcia?
Yes.
Doug Drager. I was wondering if are you guys developing filters using the pressure data of the OBS?
Yes, that was the plan. That was the plan.
And the data is being telemetered to the USGS currently.
Yep. So you can,
Will it be raw data?
yeah.
Or will it be the filtered?
No, it's raw
Okay,
data. I mean,
yeah.
right now, all of the data, including the differential pressure gauge.
So
Yeah.
it's already parked at the NCEDC then?
Yes,
Okay, great.
yes,
Have
yes.
to take a look at that.
Right, so hopefully there will be 3 more. We only have 1 pressure gauge.
Yeah.
I just decided to just get 1. But hopefully the other 3 stations will be in operation by mid-November, and they will also then be included.
What was the distance again for the magnitude 4? That was required?
It's about 40 kilometers,
Okay.
yeah, down near Point Conception.
Hi, Marcia.
Hi.
Can you tell me again how long the temporaries were going to be in place?
Yeah, they've been since July 27. That's when they were dropped down, and so it's actually more like 3 months, because we'll get them up on about November 12th.
Okay, and that's at that point then you can extract the data from them?
Yeah, that's the plan. And so our vendor Geralt, we have a part of our contract with them. They will be downloading the data, and they're going to be doing. And I get the data, we get the data, which we'll make available. But also, they will be doing a noise survey. They're going to be doing a noise analysis
Okay, thank you.
for us. That was part of the deal.
Okay, thanks.
Other question?
Okay.
All right,
And
thank you,
I have
Marcia.
2 references. Okay.